Welcome to Geometry SOL Review, Parallel Lines and Transversals. For this video, you're going to want 7 different colors. Go ahead and pause the video and find either color pencils or crayons or highlighters. Feel free to share with somebody near you, and then you can come back and restart the video. Now that you have your color pencils, let's talk about the 7 different angle pair relationships. These are examples of 7 different angle pair relationships. The first 2 are made by only 2 lines intersecting, such as the vertical angles, angles 1 and 4. Those angles are only made by these 2 lines intersecting. This intersection has nothing to do with these angles up here. So let's see those vertical angles, angles 1 and 4. Notice how they are across from each other, and again, made by just these 2 lines intersecting. Then we've got the linear pair of angles, such as angles 6 and 8. 6 and 8 are here. Notice the word line in linear pair. Angles 6 and 8 together make up this line. Again, this is another example of where the angles are made by just 2 lines intersecting. Then we've got these 5 angle pairs that are made by 3 lines. So you have 2 lines that go in some direction and then a transversal, which is the line that crosses the other 2 lines. This is the transversal. It crosses this line and then it crosses this line. First, we'll talk about the consecutive interior angles. The angles 3 and 5 is an example of consecutive interior angles. So you'll notice we have some angles that are called interior and some angles that are called exterior. When we see the word interior, we want to think of inside or between. So these 2 lines that look like they're going in possibly the same direction, between these 2 lines is the interior space. So these angles here are interior because they are between the 2 lines. If the angles are not between the 2 lines, such as out here and out here, they are called exterior. The consecutive part of the name, you want to think of same side, consecutive or same side. So these angles 3 and 5, which are here and here, notice this obtuse angle and this acute angle, that's an example of consecutive interior. Here's the transversal, they're on the same side of it, they're both on the left, and they are between the 2 lines. Then you have the consecutive exterior angles, such as 1 and 7. So here's angle 1 and here's angle 7. Notice again they're on the same side of the transversal. They're both on the left side, but now they're not between the 2 lines, so they are exterior. Then we have the alternate exterior angles, such as angles 2 and 7. Here's angle 2. Here's angle 7. They are not between, that's why they are exterior, but now they are alternating sides of the transversal. One's on the right, one's on the left. Alternate, like going back and forth. That's alternate exterior. Then, of course, we also have alternate interior angles, such as angles 4 and 5. Here is angle 4. And here is angle 5. Those are between the 2 lines, but they're alternating sides of the transversal, one on the right, one on the left. Finally, we have the pair of corresponding angles, such as angles 2 and 6. 2 is right here, and 6 is right here. Corresponding means being in the same positions. Angle 2 is the top right side of the intersection. This intersection here, angle 6, is the top right side of the intersection. Those are in the same positions. Now, when we have parallel lines, it's important to remember that the lines will be parallel. And notice in the word parallel, the double L, that's the symbol for parallel. The lines will be parallel if and only if the big angle equals the big angle, the small angle equals the small angle, and the big angle plus the small angle equals 180 degrees. So for example, we go back and look at our picture, and if these two lines that look like they're going in the same direction are to be parallel, then any small angles will all equal each other. Any big angles like 1, 4, 5, and 8 will all equal each other. And if we have a small angle and a big angle, they will add up to 180. So these consecutive interior angles, 3 and 5, that's a small angle, acute, big angle, obtuse. So these two have to add up to equal 180 degrees. 1 and 7. 1 is an obtuse angle, big. 7 is an acute angle, small. So big angle plus small angle, again, those will have to add up and then equal 180 degrees. But then we have the alternate exterior and alternate interior angles, such as 2 and 7 or 4 and 5. 2 is acute, small. 7 is acute, small. Those are equal in measure because they're both small. Angles 4 and 5. 4 is obtuse, 5 is obtuse. Big and big, they have to equal each other, just like 2 and 6. 2 is small, 6 is small. Both acute, they equal each other. Usually, try to use the picture to help you out with that. So again, this is when lines are parallel, that the same size angles equal each other, and different size angles have to add up to 180. Now sometimes you have a picture with many different lines, or the lines don't really look parallel. I always suggest start by identifying the transversal. The transversal is a line that crosses the other lines. So that's this, the transversal. And then pick a place to start highlighting the angles. For example, this obtuse angle right here. If I color this angle and then across from it, those two angles, the vertical angles, are equal in measure to each other. Now, if I follow that pattern where I'm going from top left to bottom right, and I do that at every intersection, then I can use coloring to help me notice which angles should be equal and which angles should add up to 180. So for example, in this picture, of course we could say if the lines are parallel, all the big angles should equal each other and all the little angles should equal each other. Or I could remember that when I have parallel lines, remember my symbol for parallel, then I know that the same colors equal each other. So if I colored yellow, then yellows have to equal yellow. White, the ones I didn't color, have to equal each other. And then if one is yellow and one is white, then they have to add up to 180 degrees. So whether or not they actually look big, small, parallel, whatever, I can use my color coding to help me with that. So for example, if this angle set 100 degrees, this angle set 100 degrees, and then this angle said 99 degrees, which is really close. Even though these two lines don't look parallel, I would know that they have to be because yellow angle is supposed to equal the yellow angle. So these would be the two lines that are parallel to each other. Now sometimes you have a picture with lines crossing in multiple directions. In that case, take something to cover up one of the lines and then highlight with just one of the transversals. So again, I could see once I cover this up that I highlight this transversal and then I pick an angle to start, color the angle across from it, and then do the same pattern down at the other intersection. And then I can ask myself, what are the angle measures shown that are given? What do they have to be if I want these lines to be parallel, or whatever else the question asks? Now I could also move what I'm covering up to one of the other lines going in a different direction, and then highlight elsewhere. So for example, now I have two lines going in this direction, and I'm wondering if they're parallel. So either with a different color or I erase what I had before, I can trace the transversal and then highlight using my other color from here to here, and then following in that pattern here to here. And then I can ask myself, if they gave me angle measures, are the ones that are the same color equal? Because they have to be if these lines are parallel. Is a white one and a colored one adding up to 180? Because they have to be if these are parallel, such as maybe they give me that this angle was 100 degrees. Then I would know that for these lines to be parallel, this white one would have to be 80 degrees. See how that works? Thanks for watching. Have fun with your practice.